Okay, so project two is going to be a little bit more involved than project one. I am taking it up a level. The first project was really to get you guys into the groove of how projects work, but this one's going to take a little bit more thought and probably a little bit more time. So the first thing you're going to do is you're going to, just like last time, you're going to collect 20 to 30 quantitative data points, not categorical. So make sure that whatever you're gathering for data is quantitative data that you're collecting from people, because you guys are going to also want to make sure that this data will be symmetric. So it's a data set that you really have to think about it first that will yield symmetric data. If your graph ends up being slightly non-symmetric, then that's okay too, because it's such a small data set. But definitely don't do anything with skewed values that you know right off the bat. So you're trying to go for a symmetric data set. So once you do that and you get your 20 to 30 values that you've collected, then you're going to graph the histogram of your data. So let's say that you decide to ask, if you asked the number of pets, more than likely you're going to get a skewed distribution, because you might get that person that has a lot of pets in there. So I'd stay away from questions like that. I would go for a continuous distribution, like maybe how many hours of sleep you got last night. Continuous, like time is a really good one for that. What is your age in months? That's a continuous distribution. And you would more than likely get some kind of symmetric data if you were polling your friends. Now, if you pull in your little brother for that one, then that might be an outlier. So just really think about what your data is going into it. You're going to graph the histogram. That's going to be 5 points. Please provide the data as well. Okay. In fact, I'm going to add it right now. Graph the histogram of the symmetric data and provide data like last time. I'm glad I caught that, because I would like your data as well. You're going to identify the mean and standard deviation. The way that I would do that is I would put it into either my calculator, or I would go to the Staplet that we've been doing, and you can get mean and standard deviation once you put in all your values. In fact, for this one, I probably would use my Staplet for all of it, because it'd create a beautiful histogram. It would give me my mean and standard deviation. The next ones, though, you will have to do. You're going to calculate the z-score for two separate values in your data set. One of them must be a positive z-score, meaning higher than whatever your mean was, and you're going to calculate one for one lower than your mean. And then you're going to go to your table and you're going to tell me the proportion of people that are below that. If you guys come to my Thursday meeting, I'll be showing you this example. This will be one that I work through for you. Number two, you're going to explain in your own words what it means to have a z-score of +2 on an exam. A hint on this, you guys had it on your quiz as well. This is an important one to really understand what it means to have a +2 on an exam as your z-score. So that is your answer. In number three, it says if you have 300 students that took an IQ test, and the data found that there was a symmetric distribution with a mean of 110 and a standard deviation of 9, you guys are going to draw the normal distribution and label the standard deviations. What I mean by that is specifically show me those 1, 2, 3 standard deviations away. You'll take 110, you'll add 1 standard deviation, add 1 standard deviation. So I need to see that beautiful where all 7 values, okay, the 3 standard deviations and then the mean, all 7 values are located on that normal distribution. After that, you are going to calculate the probability for a group that gets at least 119, one that has an IQ score of 98 or less. So you're calculating the areas. You're going to have to do z-scores for the next 4, and then look up the areas here. Okay, number 4, I ask you guys to explain what the 68, 95, 99.7 rule means in terms of normal distributions. You can look that up, or you can go back to lesson 2 or actually lesson 3. So it was module 3, lesson 3. If you look there, I have a video of me talking about the 68, 95, 99.7 rule for that one. Number 5, if the ACT results follow a normal distribution with a mean of 28 and a standard deviation of 4, What would you need to score in the top 5% of scores to get into Stanford University? We did actually several problems on, I guess that would have been Tuesday for this lesson. We did several problems on Tuesday, whether you were in my Zoom session or if you went through and actually looked at the videos and the work. I actually did 5% a couple times. So go back and watch those videos in this week's lesson on Tuesday if you have any questions on that one. And the very last one is a comparative one. Allie and Luke are my son and daughter. They are qualifying for West Hills High School Championship swim meet. Allie swims 200-meter backstroke in 2.14 minutes, and Luke swims the 100-meter freestyle in 1.45 minutes. Based on the following information, who performed better in their race? Because remember, those are apples and oranges. You're comparing apples and oranges, but you can compare their z-scores, okay, to the normal distribution. So for my daughter, you can compare hers to this one. For my son Luke, you can compare his to this normal distribution, the 100-meter freestyle, and you can figure out relative to the other people doing those races, who did better. Remember, it's a race. This is very similar to the problem that we did last week in here, where you want to think about, is it better to have a lower z-score or a higher z-score in this one? So that is the last one that you guys have on your project. If you have any questions, stick around on Thursday. I will be showing this one on Thursday, number 1, and then I might touch on a couple more. But if you have any other questions, feel free to email me.